Students, today we are going to introduce the functions and classifications of dynamic routing protocols. Routing protocols are divided into two main categories: static routing protocols and dynamic routing protocols. Static routing protocols are manually configured by network device administrators, and each route entry is manually input. Dynamic routing refers to the mechanism in which routers running dynamic routing protocols regularly exchange routing information with other routers. They use the learned routing information from other routers to automatically establish their own routing tables. Common dynamic routing protocols include RIP, Routing Information Protocol; IGRP, Interior Gateway Routing Protocol; OSPF, Open Shortest Path First; ISIS, Intermediate System to Intermediate System; EIGRP, Enhanced Interior Gateway Routing Protocol; BGP, Border Gateway Protocol. All dynamic routing protocols share the following common points. The same routing protocol is running in the network. All routers running the same routing protocol will send their relevant routing information to other routers in the network. All routers will generate routing information for corresponding network segments based on the learned information. All routers will periodically announce their own states, route updates, to their neighbors. The following diagram shows all the routing protocols used from the appearance of routing protocols in 1982 to the year 2000. Compared to static routing protocols, the main functions of dynamic routing protocols are as follows: discover remote networks, maintain up-to-date routing information, select the best path to reach the destination network, find a new best path when the current path becomes unavailable. Routing protocols consist of the following components: data structures. Some routing protocols use routing tables, databases to perform the routing process, and this information is stored in memory. Algorithms. Routing protocols use algorithms to calculate routing information and determine the best path. Route protocol advertisements. Routing protocols use various messages to discover neighboring routers, exchange routing information, and perform other tasks to obtain and maintain accurate network information. Compared to static routing protocols, dynamic routing protocols have the following advantages: less administrative effort when adding or removing networks, as the administrator has to do minimal maintenance on the routing configuration; automatic adjustment when changes occur in the network topology, less prone to configuration errors; good scalability, ensuring smooth network growth. However, dynamic routing protocols also have some drawbacks compared to static routing protocols. They consume router resources, CPU time, memory, and link bandwidth. Administrators need to possess a deeper understanding of networking to configure, verify, and troubleshoot dynamic routing protocols effectively. Next, let's take a look at the classification of dynamic routing protocols. The diagram below shows the classification of dynamic routing protocols, and we will now explain it. Routing protocols can be classified into IGP, Interior Gateway Protocol, and EGP, Exterior Gateway Protocol. Interior Gateway Protocols, IGP, are used for routing within an autonomous system. The main dynamic routing protocols for interior gateways include RIP, EIGRP, OSPF, etc. We further divide interior gateway routing protocols into distance vector routing protocols and link state routing protocols. Exterior gateway protocols, EGP, are used for routing between autonomous systems. The main dynamic routing protocol for exterior gateways is BGP-v4. As mentioned earlier, interior gateway protocols, IGP, can be divided into two categories: distance vector routing protocols and link state routing protocols. Distance vector protocols are suitable for the following situations: simple and flat network structure without the need for special hierarchical design. Administrators lack sufficient knowledge to configure link state protocols and troubleshoot them. Specific types of network topologies, such as star-shaped networks. No need to focus on convergence time under worst network conditions. Common distance vector protocols include RIP, RIP2, IGRP, and EIGRP. Link state routing protocols are suitable for the following situations: networks with a hierarchical design, which is often the case in large-scale networks. Administrators are very familiar with the link state routing protocols used in the network. Networks with extremely high requirements for convergence speed. In general, the algorithm of link state routing protocols is superior to distance vector routing protocols. Now, please complete the following assignments. The above is the content of our class today. Everyone, please review the material carefully after class. In the next class, we will provide an introduction to the configuration of the RIP routing protocol. See you in the next class.